Okay, we learned about forces, and we learned about a specific force called friction. So we know that friction acts in the direction opposite the movement of an object, and it has to do with two surfaces in contact. So what we learned before is that if an object is moving this way, and we're always going to call the direction in which it moves positive, if I'm pushing on it and I have an applied force, we know that friction acts in the opposite direction. We also know that the weight of an object acts down, and then because of Newton's third law, when the weight is acting down, there's a force that pushes up, which is called the normal force. So some of the things that we have to keep in mind is frictional force is always going to be parallel to the surfaces in contact. And we also have to keep in mind that the normal force is perpendicular. I'll just do the symbol for perpendicular. It's always going to be perpendicular to the surfaces in contact. That's the perpendicular symbol. Do you know that? Okay. So, why is this important? Because today we're going to do friction where angles involved. So we're going to be doing two types of problems. The first type of problem we might do is where I have an object like this, but instead of the applied force going parallel, the applied force might be pulled at an angle. When you're in the grocery store and you push on the cart, are you pushing like straight across like this? No, because you're taller than the handle of the cart, so you're pushing down. If you have a box and you're pulling for a rope, you're not pulling parallel to the floor, you're probably pulling with an angle like this picture right here. So let's say I'm moving this way. The applied force I'm pulling, the frictional force is still going to go parallel, my weight is still going to go down, and my normal force goes like this. Now, when I'm going to go through the same steps I did before, in every problem, I'm still going to have 3 steps, 1, 2, 3. But with problems involving angles, before I can sum forces horizontally or vertically, I have to take this applied force and I have to break it up into horizontal and vertical components. So I'm going to still have this, I'm going to have my weight, I'm going to have my normal force, but instead of my applied force like this, I'm going to find my components like this, FAX and FAY, and then they would tell me this angle theta. So I would replace FA, and I'm going to have here FAX, and then I'm going to have FAY. Then what I'm going to do is I am going to do the same 3 things I do in every problem. Here's the most important thing about what we're going to do today. You can't memorize like this is equal and opposite that because every single problem is different. So the first step that we're going to do is we're going to draw our picture of what's happening. That's this. Then we're going to take, so number 1 is going to be draw my what's happening picture. And my what's happening picture is actually my free body diagram. And my free body diagram shows all the forces going in the direction in which they act. Okay, the next step is I'm going to break up any force or forces that are not perpendicular or parallel to the surfaces in contact. So what I mean is this one doesn't go perpendicular. Remember, here's my surfaces in contact. So here's my surfaces in contact. So we have perpendicular and parallel. So any force that is not perpendicular and parallel, which is just that one, I'm going to break it up into its components that are perpendicular and parallel. So then I'm going to redraw my diagram with all the forces going perpendicular and parallel. And then after that, I'm going to do 3 things, and that's how I'm going to solve every problem. So the 3 things are, I am going to sum forces horizontally. I am going to sum forces vertically. And I'm going to use my mu equation. That's what I have to do on every single problem. What I'm not going to do is I'm going to memorize, like, oh, this is equal and opposite that, because what you're going to see today is every problem is completely different. If you try to memorize, you will not understand at all. Now, what we're also going to do today is we're going to do problems on an inclined plane. So in this particular case, let's say this is what's happening. So I have a box and I'm pushing it up an incline. So that's my applied force. Friction is going to go in the opposite direction. The normal force is perpendicular to the surfaces in contact, but the weight acts down. Now, all these forces are not perpendicular and parallel. The one that's not going is this one. So I have to redraw that. Now, this is the part where our geometry comes in handy. Do not memorize this. So remember, if my weight is acting down, and this is where some of you, depending upon what you've learned in geometry, some of us can conceptualize things a little bit better than others. What I would do is, if you look here, first you're going to draw one that goes perpendicular. Remember, here's my surfaces in contact. So first I'm going to go like this. Then from the head of this one, I'm going to do another one, and I want it to go parallel, so I'm going to go like this. So this is my right angle. Now this is the geometry part. If I took this angle here is similar to this angle here. So let me just show you that real quick, because some people have a difficult time conceptualizing that. So let's say I have this triangle here. So here's my 90-degree angle. And then this is this angle here, theta. Does everyone see that? So now what I'm going to do is I'm actually just going to flip this around. Whoops. It's hard to do. Flip it over. And that's like this part here. Okay, so those are similar triangles. Okay. So that angle here. So what I do is I take my weight and I break it up into the components. And instead of calling it perpendicular and parallel, we'll just call it X and Y. So then I redraw it and I sum my forces. Okay? Now, here's another big mistake that people make when we do friction. Is there always, let's say a block is moving down an incline, is there always going to be an applied force? No, there's not always going to be an applied force. So let's say I have an incline. So here I have a clipboard, and the point I want to make is if this angle is great enough, you don't have to push or pull. You don't have to push or pull. That gravity is going to pull that down. So I'll demonstrate that in a second and show that to you. Okay? So the key here is you don't always have an applied force. All right? So the best way to understand this is just working problems, because practice makes perfect. Okay?